Hi, students. I want to share with you on how to take care of filling out the reaction time, reaction distance, and stopping distance lab sheet that you will receive. So you've actually already done 90% of the calculations needed to do this, but I just wanted you to transfer the information over to the sheet so that we can have it kind of in an organized way, and you can add the stopping distance component to this because we want to get the total stopping distance, okay? So for the undistracted side, it's going to look very similar to the distracted side. But what you're going to do from the 3 trials that you completed, remember you actually recorded the catch heights already. You should have 3 of them. And then you should already have your calculations of your reaction times. So you can put that calculation here and you'll have your 3 reaction times. And then what I need you to do is then transfer those times down to this next part of the lab sheet. So just put the reaction times here that you've calculated above. And then we're going to calculate the reaction distance. Now, for this, you're going to use like the 50 mile per hour calculation that we did, and we converted that to meters per second, and that will be 22.2 meters per second. So for the reaction distance, all you're doing, since you're just coasting and moving at constant velocity, you're going to simply just multiply that reaction time times the 22.2 meters per second, and that will be your reaction distance. And you will repeat that for each of your reaction times that 22.2 meters per second. So you get your 3 reaction distances. And now for the stopping distance, now this is just going to be a given number because we're going to use that acceleration, that negative acceleration that we kind of started talking about in the slides related to this. That acceleration was around like negative 16 meters per second squared, and we got a stopping distance of 15 meters. And this is where it says given, we just simply want you to write 15 meters here. I'll show you how that was calculated in a few minutes, but everyone's going to have the same stopping distance of 15 meters, okay? So just put that number here. And then for your total stopping distance, which is over in this column, you're going to add your reaction distance plus your stopping distance, and that will be equal to your total stopping distance, okay? So just repeat that 3 times for each of your reaction distances, stopping distance, and so you will just do that 3 times. Then you'll just get your average stopping distance, okay? So this is for the undistracted. And you're going to do the same thing, guys, for your distracted reaction times. So you have your 3 heights that you worked on. You have your calculations for your reaction times here. And then in this part of the table, just like before, just like for the undistracted, you're going to put your reaction times here. Calculate your reaction distance in the same way. Again, use your own reaction time times the 22.2 meters per second, and you will get that reaction distance. And again, here for stopping distance, just go ahead and put the 15 meters here for each of those. Stopping distance, the total stopping distance, and then get your average, okay, just like you did for the undistracted, okay? So let me just quickly show you about what we were saying in terms of the stopping distance. So let me go up to a few more slides here about what we did for reaction distance, just to refresh your memory. So for the reaction distance, again, you're just moving at constant velocity. And this is the kinematic equation for constant velocity here. And this 22.2, that's the 50 miles per hour that was converted over to meters per second. And instead of 0.5, you will put your reaction distance. I'm sorry, reaction time. You put your reaction time. And so you'll get your very own reaction distance, okay? So this was just an example that we did where it was for 50 miles per hour and just a reaction time of a half of a second. Okay, but you use your own reaction time. Okay, and then for the stopping distance, we calculated it in this way. Okay, so this time you are slowing down. So that means your initial velocity is your 50 miles per hour, or again, the 22.2 meters per second. The stopping the final velocity is 0 meters per second, of course, because you are coming to a stop is 0 meters per second. And then we used an acceleration of negative 16. So we calculated, okay, what is your actual stopping distance? What is the distance traveled while you're actually braking? And so we used that third equation, that third big three equation. And this is how we calculated the delta x, or the x final actually. And so that will be your 15 meters, okay, which is on this slide here, okay. So what we're talking about, guys, just to summarize, the reaction distance is when you're moving at constant velocity, you multiply that 22.2 meters per second and times your reaction time. You get that first part, reaction distance. The second part is your braking distance. And again, I want everyone to use this 15 meters here, all right, for your braking distance. So that means your total stopping distance here, so I'm going to highlight there, is that you're just adding those two distances together. Your reaction distance plus your stopping distance. And then your braking distance, and then you have your total stopping distance here. And for this example, it is 27, okay? So that's how I'd like for you to finish out that page with all of the data just kind of compiled in an organized way. And that's how you complete that sheet. All right, thank you.